Problem number 26. Let g be a function defined by this integral. This is function f of t right here, and we want to find these values of g. So first, let's find g of 3. G of 3 means that we replace this is the definition of g, so therefore we replace the upper bound by 3. And then we look at the graph of f, and we look for the area from 2 to 3, okay? So we know that the area from 2 to 3 is this portion, and that area is going to be a half. Area is going to be half. So when we look at the integral, the value of the integral will be negative a half, because any region that falls below the x-axis takes on a negative value for the integral, so that's negative a half. So we found g of 3. Let's find g prime at 3. So g prime at 3. G prime at 3. To find g prime at 3, we first need to find g prime first, and then we plug 3 in. So to find g prime, we take the derivative of both sides. The derivative of the left side, g prime. The derivative of the right side is f evaluated at x, okay? In other words, g prime is f, so we're looking at the graph. So this is the graph of g prime, because g prime is f, so this is the graph of g prime. So we now want to find g prime at 3, so you go to 3, 1, 2, 3, and then the output is negative 1. So therefore g prime at 3 is negative 1, because this is the graph of g prime. Okay, and then we want to find g double prime at 3. So to find g double prime at 3, we first need to know what g double prime is. Well, g double prime is the derivative of f. Take the derivative of both sides, you get the derivative of f over here. Relating the graph of g prime to g double prime, the slope of this graph is g double prime. So we want to know what is g double prime at 3, which means that we want to go to 3, and we want to know what is the slope at 3. And the slope at 3 is undefined. Okay, undefined. There you go. Oh, okay, so we're done with those. Let's move on to part B. Find all the x values where g attain a relative maximum. So we want to know where does g function have a relative max. Now this is the function g right here. To find where g has a relative max, we need to find g's critical points. And so to find, so we need to look for critical points, and that is the point where g prime equals to 0. Those are critical points. So this is the graph of g prime. So where does g prime equal to 0 or undefined? G prime equals to 0 at 2 and also at 4. Okay. So critical points are at x equals to 2 and x equals to 4. 2 is a critical point because it touches 0, and so is 4. Now 2 is a max, 4 is not. So we say that g has a relative max at x equals to 2 because g prime changes from positive to negative, and that's why it's a max. Okay. Find the absolute minimum value of g on the closed interval. Okay, so to find the absolute minimum value of g, we need to check the endpoints. So these are endpoint. Okay, and we also need to check the critical points. Now from the part B, we know that the critical point that gives us a minimum value is actually at 4. Okay, so at 4 right here. So that is our critical point. So now we need to check them. So we need to check what is g at -2. Well, g at -2 is the integral. So go back to the definition of g and plug from 2 to -2. So from 2 to -2 of f, which equals to, we have to kind of flip the bound like that. Let's see what is that, what this equals. So from -2 to 2, which is half, which is a semicircle, and the area of the semicircle is the area of the whole circle. This whole circle is pi r squared. That's the area of the whole circle. So 4 pi. So the area of half a circle is 2 pi. Okay, so 2 pi. So so g of -2 equals to 2 pi, because that's half a circle. But there's a minus sign in the front, so it makes it minus 2 pi. We also need to check g of 4. Okay, so g of 4, that's one of the critical points. So g of 4 is the area from 2 to 4. So from 2 to 4 of a function f, from 2 to 4, that area is 1, so therefore it's going to have a -1 as its output. And then the last, we check for 5. So from 2 to 5, because that's how g is defined, right, of f. So from 2 to 5, if you look carefully, from 2 to 5, from 2 to 5 you got a 1 down here, and then you got a half up here. So therefore half minus 1, that gives you -1/2. So the absolute minimum value is going to be at -2. So absolute min value is -2 pi, and there you go. Okay, because that's the smallest out of, we compare this guy with this guy and with that guy, and that's the smallest. Find the x-coordinate of the inflection point of the graph of g. Now for inflection point, we need to look at the second derivative. So this g double prime equals to 0 or undefined. Okay, that's how we find inflection points. Now this is the graph of g prime. So by studying the slope of g prime, we get g double prime. So we can kind of see that g double prime equals to 0 at 0. G double prime is undefined at 2. It's also undefined at 4, and that's it. So it's going to be at, so the possible inflection point will be at 0, 2, and 4, but only inflection point only happens at 0, and also at I'm sorry, that should have been 3. Okay, this should have been 3 right here, not 4. So cross that out. That should have been 3, and that is another inflection point right here. So 0 and 3, because g double prime changes sign at these points, and therefore those are inflection points. On what x interval is g increasing? Okay, well, the function g is increasing, so g is increasing. We have to study its derivative when g prime is positive. So when we look at the graph of g prime, we want to know where is g prime positive, and this is the graph of g prime. So g prime is positive from -2 to 2 and 4 to 5. Okay, on -2 to 2 and 4 to 5, that is where g prime is positive. On what x interval is g concave up? Okay, so g concave up means we want to know where is g prime positive, is where G concave up. Concave up. So where is G positive? Well, where's G double prime positive? Remember that G double prime is the slope of G prime. This is the graph of G prime. So G double prime is positive from -2 to 0 because the slope is positive, and also from 3 to 5. So -2, 0, 3, 5. So on -2, 0, comma, 3, 5. Okay? Very good. Find the average value of f. So let's set up the integral for the average value. So this is how we find the average value. The average value, okay? Now from part C, we found that this value, it's actually -2 pi. So we did it already. And then this is 4, so therefore the average value is -1/2 pi, and we're done.